on biodiversity, on the economy, on the society at large. I mean, it's a credible evidence that it's difficult to support investment decision and integrate nature-based solutions systematically into policy and planning framework. But at the same time, I mean, the global context is quite serious. I guess that many of you have seen, I mean, the recent UN reports that has warned about the risk of water bankruptcy. This, I mean, highlighting that water scarcity, the ecosystem degradation, the pressure climate are really accelerating in a way that it is not, I mean, absolutely not sustainable. And for Europe, this also underlines the need that strong actions within the framework of the water resilience strategy can be taken soon and supported by operational tools and absolutely sound evidence. So today's webinar aims at contributing to this effort by strengthening the knowledge base that enables better decision and more effective advocacy. I really look forward, I mean, to the contribution of our speakers today and to a constructive exchange. Once again, a lot of thanks, I mean, ton of thanks to expert groups on water and biodiversity, Water Europe. Thanks to my colleagues, collaborators, top, I mean, my colleague Tiffany, Scaf, and Joanna Oprizan for making, supporting, I mean, the realization of this event. And I gladly give the floor to the leader of the expert group on water and biodiversity, Sarah Ehman from Aveco de Bond. Thank you all.
Thank you so much, Andrea, for introducing this website of this webinar in this way. We will presenting to you two really good speakers, both providing their side on improving the monitoring of biodiversity in a water-related environment, which is, as we state, a very important part of Water Europe, since it gives a good indication of the health of our water system, of our smart water system, and thus helps this whole subject forward. Water biodiversity, very shortly, what does our group do? I will not take too much time. As Andrea said, my name is Sarah Ehman. I work for an engineering company called Aveco de Bond in the Netherlands. We try to enhance the capacity of key actors in the water sector to combat ecosystem degradation and biodiversity decline. So that is water and biodiversity for all people that are acting in the environment with water, which could be in an urban environment or in a more rural environment. But this webinar really focuses on the nature-based solutions in urban environments, since we think there is so much to gain there. There's so much water management done. And well, while we are acting in improving our stormwater resilience, we can also take into account the possibility of improving biodiversity at the same time. And we really like, well, as the second bullet says, to support mainstreaming of thinking in that way. So that's why we want to present to you this two speakers today. But before I start doing that, I have one question, because I really like to have your interaction as well, and your opinion. What is your personal relation to today's topic, also to provide us with an idea of who are coming here? So you can go to menti.com and then 59304465, and I'll be asking your opinion twice now, and then in the end, Pia will do the same thing. So very shortly, could you tell me why you are here? And I'll be silent for a second to see things coming in. I want to learn more. I'm just going to read out a few quick answers and then we'll continue. I see that learning more about the impact, learning more about consultancy work and research, gain knowledge on biodiversity, nutrient runoff monitoring. So it's very diverse. There's a senior water officer from Australia. Welcome. Very warm welcome. Interested in the topic, studied environmental engineering. Yeah, knowing about monitoring biodiversity in NbS is really a thing I see coming a lot, and of course that is the topic. But it goes to functionality. I see microbial ecology. I see evidence for advancement. So a lot of good reasons, I think, to be here. India working on implementation of NbS for improving health. So thank you very much. In the last slide, we will also ask, like, if you want to give us more input, we're going to ask for your email address. But for now, I see there's a lot of diverse, but mainly focusing around want to know more about how to use the monitoring of biodiversity in NbS. How do you actually do that? Because it turns out not so easy. So I'm going to the next slide, and that is a very simple one. Is there any words that come to your mind when you think about biodiversity monitoring for nature-based solutions? There's one more question, and I will stop asking things from you when we'll start telling things ourselves. But I do think it's a very, I'm really curious whether everybody is searching, or whether people have ideas, or whether it's too complicated, or whether it's a nice, how do you feel this, this challenge? I see a lot of different things. Cause-effect relationship, what methods, multi-species, KPIs, complex counting, ecosystem services. I will make this into the slides afterwards, so I'll show you this screen, but sharing the screens is not so fast in the Zoom system of my computer, so I'm not going to try that. Observing sequencing, I see a lot of DNA related terms, but I also see the cause effect, like what are we doing and what is the impact of what we are doing. Well, that's great, because that's also what Ursula is going to try to give us a good example from. So again, please keep on putting some words, but I'm going back to this presentation. Am I still sharing my screen for you? Could anybody give me a hint?
Yes, now you stopped.
I stopped? I did not want to.
Now we see you.
No, that's nice. I'll share a screen again. It's this one. Yeah. Share. What are we going to tell you today? We have two, or actually three speakers. We have Facundo Odrizola, who is a water agricultural and water policy officer at IUCN, and he is going to take us into the IUCN standards for NbS, and then really the focus on what's happening with the standard on biodiversity. So we're very happy to present to you at least the methods that are being developed for helping you with focusing on biodiversity while working on NbS. And then secondly, we have Ursula McKnight. She's a senior researcher at the SMHY in Sweden, and she will tell us about a case study she's been doing in Denmark, where they actually did quantify the impact of measures on biodiversity. And she will also tell us how complicated that actually is, and well, what would we need it. And then thirdly, Pia Leskinen, my co-lead from the Water and Biodiversity Expert Group. She is a senior researcher at Turku University of Applied Sciences, and she will take us more into the challenges that we as an expert group, but probably the world around us as well, is having in finding good examples from this monitoring of biodiversity. So we are hoping that will also lead to more examples from your side, but it also shows where we are in this world. So Facundo, could you please take over from me?
Yes, thank you very much, Sarah, and good morning, everyone. Let me share my screen. So you should be able to see the
Yeah,
full
we are.
presentation, right?
Right.
Yeah, perfect. Yeah, so good morning, everyone. I would like to start by thanking Water Europe and the colleagues from the expert group for the invitation. In the next 15 minutes, I will try to present a very focused introduction to the IUCN Global Standard to nature-based solutions. This is a very large topic. Actually, IUCN offers a 3-week course on this, so bear with me, please. I will not try to cover everything. I will just briefly situate the global standard, what it is, why it exists, and then say a few words about the recent update to the standard that was launched, the second edition that was launched last year. And then I focused entirely on criterion 3, which is about biodiversity and ecosystem integrity, and which is also, I think, the most relevant part for today's webinar. Just one sentence of context before moving in, to mention that NbS have been part of IUCN's work for more than a decade. They started with the adoption of a definition by IUCN in 2016, 10 years ago, which was then uptaken by the United Nations at the Environment Assembly in 2022, which holds some similarities, the two definitions. And NbS are also now recognized across most major international policy frameworks, such as the CBD, the UNFCCC, the UNCCD on combating desertification, and of course the UNEA, the Environment Assembly. So of course we can see there is an uptake trend for NbS. So to go right at it, here I summarize the objectives of the IUCN Global Standard for Nature-Based Solutions. First idea is that the standard provides a robust and an evidence-based framework for having a consistent and credible application of the nature-based solutions. In other words, the idea is to help ensure that when something is called a nature-based solution, it actually meets a minimum level of quality and integrity. This uptake that I mentioned from the past decades of the use of the word indeed brought the associated use of it more and more, and sometimes not in the right context. So the idea of the standard was to bring some kind of integrity to the use of the term. In the second place, the standard is designed as an operational framework. So the idea is that it supports the assessment, the design, the implementation, the monitoring, and in general, the upscaling of nature-based solutions across different contexts. And this includes different ecosystems, different sectors, different governance levels or settings. And in terms of audience, the standard is intentionally broad, as it is meant to be used by stakeholders across diverse sectors, different disciplines, and different geographies, going from policymakers, practitioners, planners, donors, and especially local actors. So here you can get a snapshot, an overview of the IUCN standard. At its core, the standard is structured around 8 criteria, which are then supported by 27 indicators. And together, these criteria translate the NbS definition into a set of practical requirements that can then be applied across different ecosystems and contexts. I will not go through each criterion in detail, but I will briefly explain how they fit together. So criteria 1 and 2 that you can see there focus on the problem that the nature-based solution is trying to address, and on understanding the system as a whole. And this includes the ecological, social, and economic interaction, sustainability. Then criterion 3 focuses on biodiversity, ecosystem integrity, and connectivity. Criterias 4, 5, and 6 will address the feasibility, the governance, the equity, and the management of trade-offs and impacts, so more the social components. And finally, criteria 7 and 8 will focus on learning, on providing this adaptive management and the long-term sustainability and mainstreaming of the actual initiatives or solutions. All these 8 criteria matter, and as we will see a bit later, they are meant to be applied together. But I will now focus on criterion 3 because this is the ecological or the environmental foundation of the entire framework, and I think it's the most relevant for today's discussion. So here you can see criterion 3, which states that NbS must result in positive change in the state of biodiversity and in enhanced ecosystem integrity, including connectivity. We will see there are different stages for this. And this criterion tries to capture this ecological core of NbS, reflecting on the idea that biodiversity and functioning ecosystems are not side benefits, but actually they are essential conditions for the long-term success of any NbS initiative. In the updated version of the standard, criterion 3 places a stronger emphasis on ecosystem integrity and connectivity. Before it was more focused on biodiversity. And this change that the update brought means looking beyond these individual species or sites and focusing on how the ecosystem integrally functions, recovers, and remains connected over time. This criterion is structured around 4 indicators, which together guide how biodiversity considerations are built into the design and implementation of NbS initiatives. And I will now go into these 4 indicators. So the first indicator under criterion 3 focuses on understanding the starting point, basically. So before designing or implementing an NbS, the state of the ecosystem needs to be clearly identified and documented. And this includes understanding the conditions of habitats, the species, and the key ecological processes, as well as also assessing the main drivers for ecosystem degradation and biodiversity loss. The idea is that based on this information, the project consortium or the practitioners or whoever is using the standard can create a biodiversity baseline, which is essential because it will later on allow for any kind of changes in ecosystem condition or biodiversity improvements to be tracked over time. The second indicator shifts the focus from this initial diagnosis to opportunity, asking whether opportunities to restore or enhance these ecosystem functions are already identified from the get-go. So this goes beyond avoiding harm, so a negative impact, and it is about actively improving the ecosystem integrity. This is the key of this criterion of having a positive impact. And a key element here is connectivity within and between ecosystems. And this is particularly important in terms of water, for rivers, for wetlands, and for catchment areas, where the ecological processes operate across space. And this is actually exactly why NbS are expected to go beyond site-level interventions. The scale, we will not go into that today, but it's a very important factor for NbS to be considered as such. And the idea is to consider landscape or in terms of water catchment scale dynamics. The third indicator requires that biodiversity outcomes are clearly defined and measurable. This does not mean that the same indicators need to be used everywhere, but being explicit about what change is expected and how that change will be assessed from the beginning and over the time of the intervention. And these indicators are used will be based on the baseline that was done at the beginning, at the assessment moment, and these are selected to reflect the specific ecosystem pressures and the objectives of the intervention. The idea is that then the progress is periodically assessed and reviewed to allow for this understanding of whether the NbS is delivering the intended biodiversity outcomes. And finally, the fourth indicator recognizes that ecosystems are complex and that responses to interventions are not always predictable. This is also the link to adaptability, and it's a key point for NbS. As even well-designed NbS can have unintended negative impacts on nature, and this is the reason why it's very important to monitor NbS to detect these unintended consequences and to take corrective actions once these are identified. So up to now, I focus on what the global standard and particularly criterion 3 requires at a more conceptual level. The next question is how is this applied in practice, or how this can be useful for you to apply. So here I'm showing the main tools that support the application of the global standard. So with the first edition, which was launched in 2020, it was published a detailed guidance on how to use this framework. And at the same time, a self-assessment tool that I will show you now was developed to support users in applying these 8 criteria in a practical way. And this self-assessment tool was made available in 2 formats. There is an online version and an Excel version as well. And with the second edition, which was launched last year at our World Conservation Congress in Abu Dhabi, now these tools have been further developed, and the self-assessment tool is now available both as an updated Excel version and as an online tool on the NbS platform. I use this tool several times for different projects, and I can definitely recommend it. It's very practical, very self-explanatory, and it can provide some useful insights for the different phases of the implementation or development of NbS. It is important to mention that the objective of the tool is not to be a certification. We are not, IUCN is not stamping NbS, saying this is a NbS or not. That's not the idea, but this is designed to support reflection, learning, and improvement through the implementers of different NbS initiatives. So to test the standard in practice, together with the update of last year, a publication was launched applying this or presenting these 21 case studies from around the world. Here you see the publication and the geographic distribution of these case studies. As you can see, they cover a wide range of contexts in geographically, but also including terrestrial, freshwater, and marine ecosystems, as well as different regions and socioeconomic settings. And the idea behind this was to understand whether the global standard and its criteria could be applied consistently across very different types of NbS. This is, of course, a regular challenge. And one of the key findings from this work was that criterion 3, the one on biodiversity, is often one of the strongest across the cases. And this is particularly true where biodiversity and ecosystem conditions were treated as core objectives from the start. This is not always the case, as sometimes these are treated as more like secondary co-benefits. And at the same time, the case studies also highlight common challenges, especially around long-term monitoring and this adaptive management, which is, I think many of you will be familiar. Sometimes when the projects end or when the initiative finishes, it can be a challenge to provide the sustainability of the intervention. So in this slide, I am showing you an example of the self-assessment tool. This is the Excel version. And as you can see, the structure is quite simple. Each row corresponds to one of the 8 criteria of the global standard. And then for each criterion, users will assess their intervention against the relevant indicators. And then based on these inputs, the tool will calculate a score for each criterion. And then it will give you an overall result. On the right side, you can see the qualitative outputs, and this range from strong and adequate to partial or insufficient alignment with the global standard. And it's important to stress that this is a self-assessment tool. Again, as I was saying, it is not a certification, and it's not designed to exclude projects. The idea is to help project teams or implementers to reflect on their interventions, ideally early on, and try to use this to identify any strengths, any gaps, or any areas for improvements across these 8 criteria. And then for criterion 3 in particular, the tool encourages users to reflect on this ecosystem baseline, this integrity and the connectivity, and on the measurable biodiversity outcomes that are intended from the early on. Here you can see an example of the overall output of the self-assessment tool. Here the results in this example, the results from all the 8 criteria are brought together on a single overview. And for each criterion, the tool shows the score obtained. You have the maximum possible and the resulting percentage. This percentage then get translated into this color-coded output, and this makes it easy to see where intervention is performing well and where there may be some gaps. In this example, in the part below, you can see that the performance is uneven across the criteria. Some are relatively high, while others are quite low. And actually, this is a very common and very realistic outcome. It's very rare that a project will score highly on every criteria. And actually, that's not the objective, not to have perfect scores across all criteria, but actually to use this exercise, as I was saying, to identify strengths, trade-offs, and maybe priorities for improvements and areas in which the project team can focus. And you can also see at the bottom that the tool provides this overall results, indicating whether the intervention is considered to be in adherence with the global standard or not. The idea of this, as I was saying, is just to help project teams and decision makers to quickly understand this balance between the 8 criteria, and particularly for criteria 3 to highlight whether biodiversity, ecosystem integrity, and connectivity is being addressed with the same level of attention as other dimensions. And I will conclude with a very simple invitation. If you would like to explore the standard in more detail or to try out the self-assessment tool yourself, you can do so using this QR code that links directly to all the resources mentioned, the theoretical framework, the practical guide, and the self-assessment tool. And as said before, this can be used at a different stage. It can be used to reflect on an existing intervention, midway in implementation, but also to support the design of new implementation or just to structure discussion across team with stakeholders or with implementers. With that, I will stop here. Thank you very much for your attention, and I'm happy to take any questions.
Thank you very much, Facundo. for this very clear, I think, explanation of how you can actually look at your own NbS and what it is doing for biodiversity. I think a very important first step. People from Water Europe, I don't know, do you want to take only chat questions, or can we also have some live? I think it's all chat, isn't it?
Yeah.
Yeah. So please put your questions in the chat. And I think we have to continue straight away also with the next presentation to make sure everybody gets around. But we will make sure that people can also get the answers in the chat. I see here 2 first questions. No, this is only one, sorry. Can I ask if the changes in IUCN global standard are already published and available? Is the self-assessment tool already updated? Can you answer that one quickly, Facundo? It sounds like a question.
Yes. Hello, Evelyn. I know her very well. Indeed, the standard is already published and updated. At the moment, it's only online, and you can use it through the page. There is not an actual publication and resource as it was with the previous version, but it's already available online. And the self-assessment tool is also available, and it has been already updated and reflect these changes in indicators. Yes.
And the second question I also wanted to ask you, can you post the link also here in the chat? But then also, please, people, do not go to the to this standard straight away, but first listen to our second presentation, and we will make sure you get the link afterwards as well, so you can check it anyhow. Ursula, would you please take over? Because here we have the standard, and now we get an example from when you are trying to monitor the impact on biodiversity and what you run into and how you solve that. I thought it was a very interesting story you told us.
Great. Thanks very much. I am sharing my slides. Can you see my slides?
Yes, but not in the presentation mode yet.
Okay.
Yeah, perfect.
Perfect. So you see just one slide now. Correct. Great.
We do.
Thanks. Okay. I'd also like to thank Water Europe and the organizers for the opportunity to be here. And I'd like to acknowledge my colleague, Dr. Sebastian Huss from ICOSA and Institute for Biodiversity Network. He's a nematologist, without which I wouldn't have all these really exciting and cool results to show you today. And I'd like to acknowledge also many others who've been a part of the work that I'm going to show you, especially former PhD students, master students, and bachelor students writing their theses with me when I was still based at DTU in Denmark. So I want to set the scene for my presentation and for the catchments that I'll be talking about today. Peri-urban riverscapes are, of course, now ubiquitous landscapes found worldwide and reflective of the role that intensifying agricultural production and urbanization play as central factors driving global freshwater biodiversity decline. You can see a couple of examples shown here, one from Auckland, New Zealand, and one from the usual stream catchment, where we'll be jumping to next, in Denmark. And peri-urban riverscapes or landscapes, they're very relevant to the discussion we're having here today at both scientific and policy levels, right, around the design and implementation of climate adaptation measures like nature-based solutions. And demonstrate also the importance or the important connection to policy, which is driving a lot of the actions around improving landscape resiliency. So it's very, very important that we have robust policies which can help to guide us in this endeavor. So freshwater ecosystems in these landscapes are often quite heavily impacted by multiple stressors, including, for example, land use change and the subsequent habitat fragmentation and degradation that occurs from this, as well as hydrological alteration, such as flashier flow regimes that result by increasing impervious surfaces in these catchments, and especially in the urban areas and peri-urban areas. All the way to multiple chemical stressors. You can see examples for contaminant classes shown in the figure to the left, which are dynamically impacting water quality and which can accumulate in freshwater environments. So to restore and ensure these systems can reach and maintain a good ecological state according to the European Water Framework Directive, as well as many new policies coming online now, like the Nature Restoration Regulation that passed in 2024, will require holistic management approaches and quite possibly also underused bioindicators that not only tell us something about the current state, but can help us to improve our understanding of the linkages to key sources of stressors that are causing the impairment, so we can start to do something about them. And ideally also then help us to improve our understanding of the effects and role of peri-urbanization across the groundwater surface water interfaces, which is still poorly understood. And peri-urban catchments are also critical in terms of when we talk about upscaling nature-based solutions outside of cities, right, to maximize potential for reduction of biodiversity loss. Okay, let's jump into our first, and this is the case study that I will talk most about today. It's the Usel stream catchment. It's located on the island of Sjælland, the largest island of Denmark, and it's about 30 kilometers north of its capital, Copenhagen. So right in the heart of life in Denmark. Just some general catchment characteristics. It's quite small by European standards at around 120 square kilometers. It's dominated by agricultural land use, which is very typical also for Denmark. And below you can see a few additional details about the stream system. I've highlighted the flow rate. I've put it in liters per second, so it looks like there's some water in this creek system, in the creek itself. But even small streams like this can have huge impacts and consequences for the people who live there, as demonstrated in this picture here. So this is flooding in the catchment after the cloudburst of 2011 over Copenhagen, and caused large economic damages in this catchment, which actually drove a lot of what then subsequently happened here in terms of measures for flood risk reduction and additional restoration activities. So here we are between 2011 and 2015, if you will. So I'm calling this an early nature-based solution for climate adaptation, because the word hadn't been coined yet. But they were ahead of the curve. In particular, Fredensborg municipality was very keen to think about what else could be done, remeandering the straightened channels, etc., in order to enhance ecosystem services, as there were a lot of other interests in the catchment, and this is a stream system that needs to reach good ecological state, as it's being reported to the European Commission as part of the Water Framework Directive monitoring. So here's a look at how well these measures that they've implemented have worked. I happened to have a student out in the field in December in 2018 who snapped this picture for me. He was just downstream of the source of this stream. This is Sjælland Lake, which is very, very eutrophic. The picture above is from August, and the picture below is from December. And if you'll remember, in 2018, people are still talking about that all over. It's very, very intense drought year for Northern Europe and elsewhere. Okay, so then the next step, of course, is to start to consider, okay, what's going on in the catchment? What could be causing the problems that we're seeing here? It's peri-urban. That means we're going to have both urban and rural pressures. The top figure here shows a wastewater treatment plant outlet to the left. So that's where effluent is being released into the creek. And on the right, we see a separate stormwater systems outlet. And then down below, we can see agriculture, of course, and this is down gradient or in the northern part of the catchment. I want to just mention that there's also contaminated sites all over this catchment, in particular in the urban areas. The largest one is located very close to the junction, or the juncture where the Usel stream meets the final tributary and then dumps out into the Baltic about 2 kilometers further on. This is mostly about urban areas. I just wanted to show you another picture from the urban pressures side. I had yet another master's student out in the field, and this was just blind luck, if you will. It's very, very hard to capture combined sewer overflows. And he could see it because we had put out a YSI multi-sensor probe, and this event lasted around 20 minutes or so from the time when he realized something was going on. And then this is a look at a separate stormwater system outlet further down gradient in the catchment. Okay, what about ecological state? If as you can see from the figure below, or from the table below, it's mostly stuck at a level of 4, which corresponds to moderate conditions according to the European Water Quality class system. This is using the Danish Stream Fauna Index. You need a 5 to reach good status. It's been intercalibrated, and this is what they use for reporting benthic macroinvertebrates to the European Commission. It's a little bit outside the scope, but it's still important to mention this catchment has very, very complex stakeholder dynamics in terms of responsibilities for the catchment conditions, which also drives perceptions regarding the use and interest in protecting the stream. We worked very closely with Fredensborg municipality, who's located, so the water is flowing from the bottom to the top, if you will. So, and they're located down gradient or in the northern part of this catchment. And as you can see here, most of the restoration activities that they implemented were in the section that's managed by Fredensborg municipality. And in addition, so many restoration activities occurred. I didn't show all of the data. We jumped from 2006 to 27 here. And these restoration activities cost on the order of around 20 million Danish crowns. 20 million Danish crowns, I think that's a little over 2.5 million euros, just to give an idea. And it's gotten stuck. And this is the point. In 2018, they reached out to us to see if we could help them get some insights into why they couldn't get over the hump here to good ecological state. And the key message that I want to mention is that if we cannot show that the investments are working, then we're going to risk downgrading the number of catchments required to meet good ecological status, right? And this is going to impact our, so what about landscape resiliency and our ability to really regenerate these systems and bring, reduce biodiversity, freshwater biodiversity loss in particular. So the first step for us, of course, was to have a look at which stressors might be contributing. I want to stay mostly focused on the biodiversity aspects, but if we're talking about ecological quality, then we also have to talk about water quality because they're tightly linked, of course. So this slide really just to show that we conducted a very intense monitoring campaign across time and space. This was possible in part because it was due to the characteristics of this catchment that it's small. So we were able to place 11 stations along the stream stretch, which overlapped with existing monitoring stations that Fredensborg and other municipalities had put in. And then we conducted 10 measurement campaigns on almost a monthly basis in these 11 stations from October 2018 until October 2019, and then with a follow-up point in April 2020. So the first variable to look at here is the stream discharge, so the flow dynamics, as we know the importance of especially anthropogenic hydrological disturbance on aquatic ecology. And there is absolutely very high anthropogenic controls that have been put into the system, in part because of the flood risk and concern from the residents here. What we can see in this figure is that flow rates increase downstream of both the wastewater treatment plants and the tributaries. So there's 2 smaller capacity wastewater treatment plants that were active at the time of this study. They're located upstream just after station 1 and before station 2. And so we can see a small increase, small capacity. The outlier here, this is sampling point from October 2019, where we had some quite high precipitation event just before. Anyway. And then the second wastewater treatment plant, the largest capacity one here, is located between stations 5 and 7. And you can see this tributary is actually, so station 6, it's not really contributing a lot. So the bulk of the flow change we see here is from the larger wastewater treatment plant effluent entering the creek system. And then this is the Nido tributary further down in the catchment, just before it goes out into the Baltic, and we can see then its influence here. So I just want to note that it's important to be aware of actually the role that effluent is playing, especially in lowland small catchments like this, in terms of providing water to the creek. So it represents at any time of the year somewhere between 40 and 70% of the water volume. And this needs to be considered when we talk about management options, because if you remove this water, then then you will potentially risk that the creek is running dry. Final point here is that what we can also see is much higher seasonal flow variability downstream of the last wastewater treatment plant. So if you will, in this section of the the stream system, this is where the early nature-based solution restoration activities, if you will, were taking place, right? And we can see a higher variability here. Okay, so next I'm going to show you the results from ecological assessments that have been carried out using different indices, and which thus corresponds to different trophic levels. And this is important to have these different trophic levels because they respond to different types of stressors, and that's why there are 4 biological quality elements in the Water Framework Directive, right? And remember that the WFD follows the one out, all out approach. So of course, all elements must pass in order for a stream to reach a good ecological state. So the last data point that I previously showed was from 2017. Here we can see results from a consultant that was hired by Fredensborg Municipality, showing results from 2019. This is the macroinvertebrates. The benthic macroinvertebrates were sampled in March 2019. The fish were sampled in October 2019. This is when you're actually supposed to do these samplings. And now I show you results from our team, which was out there first time here in August. And we can see very similar results for the macroinvertebrates with slight decreasing, conditions in the upper catchment, so in the urban areas. We also applied the benthic algae indicator that was under development at the time of this study. So please note that it was not intercalibrated. So this color is just an indication for the water quality class. And then finally, we also carried out a screening of the Danish Habitat Quality Index. It's very important also hydromorphology. So if you don't have the habitat, then of course you won't be able to return the system to the ecological state either. And this is important because what we see here from the results is that this is also not the whole story, because we have habitat that's actually in good condition and we still have poor results. So it's not the whole story. So the key message here is that what we see is likely the role of hydrological disturbance, so anthropogenic controls in the system. I think I forgot to mention there's a sluice that controls the amount of water flowing out of the lake. And then after the cloudburst event, there's now a series of 3 low-head dams placed between stations 2 and 5 in order to reduce the risk of flooding to the community that lives along here, residents. So we're likely seeing the role of this hydrological control, but it's also, which prevents the recovery, but it's also possible that the index or that the benthic macroinvertebrates need more time to recover. Something that we discussed in our group, recolonization potential may be very low, it's just a theory. And then in the case of the fish, we can see that they're super unhappy in this creek system. And so now if we turn back to the water quality conditions, basically we got what we expected, right? So what we can see here are very, very complex seasonal water quality dynamics. The figures that I'm showing are just a small selection of the radar charts and station clusters that we generated using all general water chemistry parameters. And I just walk you through some of the examples. If we start here in the middle, this is May 2019. And if we take a look at the urban region, the physical chemical conditions are being driven, in fact, by the source of the stream, the eutrophic lake. So if you look at the red cluster, and you can see the influence of the lake actually extending all the way downstream, because the red clusters are reaching all the way downstream here. And then if we go in and look at the chemistry values, dissolved oxygen is an issue, total suspended sediments and others, etc. Also, you can see what's popping up here, the red in the radar chart. But at other times of the year, if we move backwards in time to February, then we see that there are other controls. And here now it's actually this tiny green cluster when you compare with the data. So this is the 2 smaller wastewater treatment plant outlets, and in particular ammonium and phosphate that seem to be driving impairment here. And then if we want to look at the rural system down here, so now if you'll focus on the blue clusters, we can see actually the role of the larger wastewater treatment plant driving potentially poor conditions, especially in the summertime, also notably N species coming out of here. So the key message is that we can really see shifts in the prevalence of different stressors, which shows the importance of seasonality on water quality, but which makes it very, very difficult to manage from a water resources and ecological quality perspective, right? So where to start in this catchment if you want to get over the hump and reach good ecological state. So the next step is whether we even have the right bioindicators at play to help us try to figure this out in any are out there. And so this is super exciting for me. I first met Sebastian Haas back in 2014. I think the nematodes are a very, very underused indicator that are very relevant for the conversation we're having here about nature-based solutions. You can see a list of all the reasons, all the benefits for bioindication that they could give. They're ecologically relevant for the reasons you see listed here. I've highlighted that they're ubiquitous in all habitats globally, even in extreme modified habitats. They're some of the first colonizers, making them extremely useful for when we're working in modified and disturbed ecosystems. They're also incredibly easy to sample. You can sample them almost year round. And now with eDNA and metabarcoding methods coming online, this index is also, or this indicator is more accessible now for non-specialists. One of the major benefits of the Nemosphere Index is its ability to identify chemical stress, as shown in the figure to the right, where you can see that the Nemosphere is dose-dependent related and which is related to the toxic potential of the sediments in the stream bed. So I hope in the coming slides to demonstrate its usefulness as an additional bioindicator to help us identify the causes for poor ecological quality. And we need this in order to ensure targeted financial restoration investments in catchments such as these. And here's the result already in our catchment. What you can see here is good to high ecological quality for most of the stations. And a reminder here in blue, I've highlighted where the bulk of the restoration activities have occurred. So this is our nature-based solution site, if you will. But we also we see the impacts demonstrated also in the upstream urban environment. So the key message is that early nematodes, as early colonizers and fast responders, may be showing positive effects more quickly of restoration activities in the downstream part of the catchment. But it should also be noted that nematodes are potentially less directly impacted by hydrological and or hydromorphological disturbance too. Here I'm showing an example for connecting back or connecting the impacts to sources of chemical stressors. Here I've taken total suspended sediment as the example, as it is also well known to be related to sediment contamination, where some of the most toxic pollutants will bind. And we can also see very clearly from this figure that the sources for the toxic suspended sediment are found in the urban setting, but also include the source of the stream, this eutrophic lake. And when we then connect this back to the Nemosphere Index and to our understanding of the stressors that are active in the catchment, then we can start to identify the drivers of impairment. This has been done by using a simple cluster analysis, which shows the similarity of the nematode species composition. And then, for example, so if we take stations 1 and 3, we can see the impacts of low flows, chronic low flows, if you will, and then the settling of the suspended sediment. Stations 2 and 5, these are our wastewater treatment plant effluent locations. Station 4 separates out, this is our combined sewer overflow. And it's notable that many CSOs, they occur or they're placed after a first treatment by the wastewater treatment plant setup, but this particular one is not. So there's no treatment where this is coming out. And then finally, in terms of one of the reasons why maybe we see such good conditions in the restored area is not to forget that potentially we're seeing beneficial effects actually of the effluent, because they're providing also food, if you will, for the nematodes, which eat algae and bacteria that can also be coming out in the effluent here. And as we can sample nematodes at almost any time of the year, we can also start to see a better picture of the various catchment pressures and when they may be active. And I just want to call your attention to Station 5 here. This is the largest wastewater treatment plant location. This is August 2019. It was marked green and it turned orange when we sampled it in April. And April, this is the time when you're supposed to be out sampling benthic macroinvertebrates, in fact. And so now we start to see maybe one of the key stressors that might be also preventing benthic macroinvertebrates from returning to a good ecological state. So I think hopefully I've demonstrated to you that the Nemasphere Index has successfully discriminated seasonal impacts from different urban features here as well. And then this slide is just an ecological quality summary for this catchment. It shows us that the variety of indices that are in use can help us to pinpoint the dominant stressors and their sources so that we can ensure restoration investments can make a difference. I don't want to go into the details here for the other indices, because maybe you're asking the question, okay, this is a small catchment in Denmark, and is it transferable? And I'm going to take you across the bay. We're still going to be in a small catchment, but these are hot off the press results from a new project that I have running in the Riseberga stream catchment in the city of Malmö. It has very similar issues, everything that I was just presenting about the Danish catchment, except that it's Malmö's largest stream. And has faced a series of gray solutions, if you will, that have been implemented in the last century, but has all the challenges of this century and urbanization and climate change, of course. The difference here, and why I wanted to show this, is because they have actively been putting in nature-based solution measures since the 90s. You can see a list. This is not all of them, but this just shows some pictures and some measures that have been implemented in these sites from A to E. And then they're in the process of planning a new set of measures that will go into site F. And I just want to show you briefly our preliminary results and present you with 4 key findings. The first point is that I hope that I can convince you here that the nematodes, it seems like we can confirm its ability to identify very specific catchment features that may be active as key stressors. And so if I bring your attention to site A, and you can see the pictures over here. So site A upstream, about 150 meters maybe, and then downstream where we have a separate stormwater system pipe that's coming in, right? So we can see actually the influence of this stormwater pipe. We have good conditions upstream, and then we're at moderate conditions here. So it's really nice, get that, right? So this first step, I think what we're seeing here is that it's providing evidence for enhanced ecological quality in these sites. But of course, I want to caution more spatiotemporal data is needed. Why am I stating this? So now if we compare sites A to E, and forget about B for just a second, I'll come back to that. But if we compare sites otherwise A to E with site P. So site P, this is our control site. You can see here with the pin drop that it's located outside of the catchment in a blue-green space that was not implemented expressly as a nature-based solution to our knowledge. And so we can see this first evidence, perhaps, if you will, that the nature-based solutions are working for biodiversity. Third, it's very, very difficult actually to produce a baseline. I remember when we were starting out in the Danish catchment, when I asked our benthic macroinvertebrate specialist, we were going out into the system, and he already knew by looking at the habitat that there would be issues, right? So it can be very difficult to produce some sort of a baseline. And we often lack this, therefore, in modified ecosystems where nature-based solutions are often going into. And here I want to draw your attention to site F. This is the planned area where we took a sample here, and we can see actually it has surprisingly good conditions, and this gives us something to aim for that we want to ensure that it stays that way as they're implementing their measures. And then finally, let's come back to point B. I think this shows an example of how the Nemasphere can help us identify sites which may have unaddressed stressors, in fact. Site B is located up here, if you look at the top right of the screen. And recently we found out from the city of Malmö that this is an old, it used to be an airfield, in fact. And so if I think of airfields, then I'm thinking of kerosene jet fuel. I'm thinking non-aqueous phase liquid contamination of groundwater coming up into surface water, bringing me back to my earlier comment about groundwater surface water interfaces and their role in these types of landscapes. And this is my final slide with some concluding messages. I think we still lack bioindicators that are Water Framework Directive approved, if you will, for disturbed and modified ecosystems, and which can provide all the things that Facundo has said we need to be able to do with the third criterion, right? We need a baseline status. and be able to identify opportunities for how we can enhance ecosystem integrity, etc. But it would be nice to have indicators that are sensitive to spatiotemporal dynamics and link us back to the sources of stressors so we can actually start to manage the problems more directly, and of course provide evidence for improvements in nature-based solution measures. I want to mention that in 2021, of course, the European Commission published their handbook of methods for, so appendix of methods for monitoring and evaluating the impact of nature-based solutions. But we need this evidence for improvements, right? And we still have a very fragmented understanding of what's going on in peri-urban riverscapes. I hope my talk has demonstrated that. And the issue here is that it can impair reliability and trust, which subsequently impacts policy implementation and could then therefore impact future finance opportunities when we can't demonstrate that the measures are actually doing what they should. Okay, and finally, I just want to say stay tuned. Sebastian will be giving a presentation in the third webinar of this series, actually, on where he'll go more in detail into how the nematodes are actually working and how they may be suitable indicators for nature-based solutions. And with that, I'd like to thank you for your attention, and I'm also available for questions now or in the chat. Thank you very much.
Thank you so much, Ursula. I think we all learned a lot of new things in this presentation concerning other ways to look at issues you cannot solve, looking at the normal or the well-known ways of monitoring. So thanks for this short introduction. And as Ursula said, there will be more webinars. There is no time now for direct questions here because we only have 10 minutes left. And I really want to give Pia the chance also for our last part. But in the chat, I'm sure Ursula will reply still. So Pia, please take the floor. I will share my screen.
Yes, thank you. Thank you, Sarah. So I'm Sarah's colleague in the Water and Biodiversity Expert Group, and the aim of this webinar initially was to present a number of positive cases where the biodiversity impact of nature-based solutions have been monitored and showed. And then we looked for these positive cases, and it was really, really hard to find them. And that's why we ended up having this short talk about why we should monitor the nature-based solutions and why are we not doing it. Next slide, please, Sarah. So how do we know whether this picture here presents an NbS, a nature-based solution, or is it just a bond? Well, I think it became quite clear from Facundo's presentation that to be an NbS, it must benefit the local biodiversity. It has to have some biodiversity values. So how are we going to know about this biodiversity values, this impact, if we are not monitoring them? Can you click on, Sarah? The connectivity is one thing, even if we create a really nice nature-based solutions, but if it's not connected to the local environment, if it's not interacting with the local environment, it's not also giving any benefits for it. Next, please. Yeah, the habitat quality from Ursula's presentation, it became quite clear that that's a key driver of biodiversity, and we need to make sure that the habitat quality is sufficient for any biota to spread there. And even though this can be a really nice NbS for different species to live there, it can also be an ecological trap or sink. If the habitat quality, for example, is not sufficient, it can also just attract the species, but then they will not be able to live there for a longer time, and the populations will die after a few years, for example, and then that can be an ecological sink. Next slide, please. So why should we monitor? Of course, Facundo's standard is a good aim, but standards are just tools. I think the most important reasons for monitoring from like a point of view of a company or a municipality that is investing on those nature-based solutions is normally there are some needs for reporting, accounting. Municipalities, cities nowadays, many of them have strategic goals of nature positivity, for example. They need to be able to show that they are the measures they are doing are driving towards the strategic goals. But I think even a more important reason is learning. If we don't monitor, if we don't learn about the biodiversity impacts of our solutions, how can we do better in the future? I'm sure that there is a lot of space for improvement, and how to maximize the positive impact of our measures to the nature. It can be small things, just the gravel size or the slope inclination or whatever. But if we don't monitor and link to the characteristics of these nature-based solutions, then we don't learn to optimize the biodiversity benefits of different solutions. Next slide, please. So why is it so difficult to find examples, positive examples, where the cities or companies would have monitored the biodiversity impact, real biodiversity impact of the nature-based solutions that they have been investing on? Well, lack of funding is one obvious thing. The comprehensive mappings of biota are quite expensive, and many municipalities, for example, they're struggling to find funding even for the investments. So I think a lot of municipalities have prioritized now the practical implementation of these measures, but then monitoring is lacking. Then the lack of tools. Well, Ursula was presenting these nematode tools, but do we have what kind of tools should be used? Can we use just some indicator species like nematodes, or do we really have to do all these comprehensive mappings of different taxonomic groups? The selection is quite complex, and it's not at all as simple as measuring the carbon, like carbon dioxide emissions or something like that the municipalities and companies are used to do. And then the lack of know-how. Maybe those organizations, like I'm now talking again about municipalities, cities, and companies that are normally the ones that are investing on the nature-based solutions, they might not have the biological know-how to do the monitoring. So how can we really connect this monitoring to the and pass on the information on the monitoring results to the engineers who are planning the NbS measures, or to the municipalities or companies who are doing the investment decisions? Also, there are some challenges in timescale, like the positive impacts on biodiversity. They develop in time, and the population evolve over time. So you would need to have quite a long time scale. So please, you could go now to the Menti and select the two most important reasons that you consider are the most important bottlenecks to the monitoring of NbS in practice.
I see that lack of funding is now the most the most outstanding one, but
yes,
people are starting to reply. I have only 7 replies, so
okay, so
a little bit more, and I'll get back to it. But I will put you also to the next slide, Pia.
Yes,
I'll give an update in 2 minutes.
Yeah, please continue responding to the Menti. Anyway, so this was just to an attempt to initiate the discussion. How could we get started? What would be the concrete things that we need in by these concrete actors like cities, companies, municipalities, that we would find resources for monitoring, how we could start using the tools, or there's already a lot of tools for biodiversity monitoring existing. How could we start using them? What do you see as the most potential way to start, and how to find how to share the course of biological monitoring, for example, between the the city and the engineering company that has been planning the measures, for example. So is there, Sarah, now more responses for the challenges?
Lack of funding and know-how are by way the most important ones.
Okay, so we're not lacking tools, but we are lacking.
No. Well, of course, there are some replies for tools, but the funding and the funding is on one, and the monitoring, the know-how is on two.
Yeah.
So I think that gives direction on where we have to
shift. That gives a nice direction. So now there is a next question in Menti, and here we hope it's an open question, and we hope that we would get comments from you. What do you need for starting to do this monitoring in practice? What kind of development or assistance or whatever? Or if you have any cases, positive cases of monitoring NbS, please let us know, and we will help you to share your case internationally. We will be writing a paper or white paper on this topic, and we would be really thrilled to get some real concrete real life examples there. So please leave your contact information.
Yeah, that would really help if people that react also give some email address so we can get back to you. And if you only want to share what you want to share right here, that's perfect, of course.
So Sarah, I think it's the time to close this webinar. We have 2 minutes left.
I want to do it in 2 minutes. I can take over now, Pia?
Yes, please.
Thank you very much for all the listening and all the information you got. I think it was intense in information. And I thank you very much for having shared your ideas and your needs. I see that the comments are still coming in, so I'm very happy with that. This is what you earlier shared, and I will not go into it due to lack of time, but we will make sure that you get the information in later on. Ecosystem services and indicators were, in the end, the most mentioned terms in the word cloud I asked you for in the beginning. Like, what do you think of when it's about biodiversity monitoring in NbS? So I think that offers a direction as well. We want to be able to measure, to also sort of make sure that we keep our ambitions. So also, like Ursula stressed this as well, we need results for monitoring to make sure that we don't turn down our ambitions because we don't believe in them basically anymore, or we have to get less because we don't have money for more. I also really like the stressing of Facundo about there is no NbS without sustainable improvement in biodiversity, because it will never work in the long term. And I want to mention again in baseline, the baseline that was stressed by both Ursula and Facundo. We will go deeper into that in the third webinar as well. But first, there's webinar 2. It's in less than 2 weeks, actually. There we go from monitoring to management decisions. So here we were just into the monitoring, but then we want to make the link in what do you need as a manager to make a next step, to decide on costs, to decide on measures. So we have 2 interesting speakers again to talk about that. So please sign up. I'm sure that Tiffany will put the registration link in the chat as well, and otherwise
I just did
on the website. Perfect, Tiffany. Thank you so much. And then there's 2 more. In March, it's about the methods. Well, as Ursula mentioned already, and I mentioned already, there's more information about baseline, and there is more information about a few different methods, amongst which the nematodes one. And in April, we will go deeper into the needs for reporting on water and biodiversity, because that is still often a reason to start monitoring, that you do need to somehow account for the results that you're getting. So we want to provide as much help for you as well in that term. And with that, I would like to close this webinar and thank you so much for being here with almost 100 people. As I said, we will get the information from this webinar to you all if you want to. And I hope that we will have as many people in the next webinar to try and spread the use of monitoring biodiversity in water situations even better. Thank you very much, and have a very nice day.
Thank you.
Thank you very much.
Bye.